Okay, guys, so we move on to the next part, and that is escalators. Okay, now escalators are pretty much similar to upstream and downstream questions we saw. Now, the only difference is, see, escalator goes down, the condition is exactly like the upstream downstream wala case. So, in the same way, agar suppose the person is basically, at the bottom, okay, and the escalator is going up, okay, that condition is like the reverse upstream downstream, okay. And the second difference between escalators and the other upstream downstream questions is, in case of escalators, the distance is measured in steps basically, okay, how many number of steps, okay, and the speeds will be measured in steps per unit time. A man can walk up in an upward moving escalator in 30 seconds. He can walk down this moving up escalator in 90 seconds. Okay. Assume that his walking speed is the same both upwards and downwards. How much time will he take to walk up the escalator when it is not moving? Okay. So what we do is we assume the person's speed to be equal to a steps per second and the speed of the escalator to be e steps per second respectively. Okay. Now, if the person is standing at the bottom, and he's trying to go up. The question says it's an upward moving escalator, right? So now the person will take a number of steps per second. The escalator will push him up, right? So the person will go fast, very fast. It will go up. Okay. And how much time does he travel for? He travels for 30 seconds. The distance he will travel is a plus e times 30. Similarly, in the second case, okay, this person is going down. His speed is same. Okay, but now the escalator is coming up. So usko zyada time lagega, right? And that is why he's taking 90 seconds. And that is why the escalator will oppose him. It is like your typical upstream motion jo ki ulta ho gaya hai na. So here in this case, the speed becomes a for the person. Escalator pulls you basically up. So a minus e. The time you take is 90 seconds. The distance is a minus e into 90. Both of them equate the same distance. So, just equate them. And you will basically solve for the ratio a is to e. So when you solve this, you get a by e equals to 2 is to 1. You can substitute the value of a as 2 and e as 1 in either of the two equations, either in this one, okay, or this one. In whichever one you substitute, okay, इसमें substitute किया, so 2 plus 1 into 30 is 90. And in this, if you substitute, 2 minus 1 into 90 is 90 steps. So 90 steps are required, okay. How much time will the man take when the escalator is not moving? Okay, that means his speed is equal to 2 units per second, 2 steps per second, right? So how much time will he take? 90 upon 2, 45 seconds. But there is a much quicker way to solve the same question. Let's see how. We see that the speeds are a plus e, a minus e, and a, right? The speed when the person is going basically down is a minus e. When he's stationary, the escalator is stationary, the speed is a. And when he's basically traveling up the escalator, it's a plus e, right? If you observe, a minus e, a, and a plus e is an arithmetic progression, right? Remember, whenever the terms or the numbers are in AP, arithmetic progression, okay, the reciprocals will be in HP or harmonic progression. Since distance is same here pe, speed is inversely proportional to the time. So agar speeds are in AP, the times are in HP, harmonic progression. Okay, so the required answer is nothing but the harmonic mean of 30 and 90. Calculate 2 30 90 upon 30 plus 90. The answer is 45 seconds. As simple as that.